Welcome back to Chemistry 2, Unit 6, Solutions 1. This is Lesson 2, Part 2 on molarity, video number 1. So molarity is something that we have seen throughout Chemistry 2, but we're going to formally define it here. This is defined as moles of solute per liter of solution. So we have to calculate moles, so we'll have to do formula mass again, per liter of solution. So the units on this are a capital M, which stands for molar. And if you use a lowercase m, that means something else. So make sure that it is a capital M. And it's calculated moles over liters. And this is our conversion factor that we can use in stoichiometry. So it's moles of solute per liter of solution. So let's look at some examples. What is the molarity of a solution containing 3.65 grams of HCl in 2.50 liters of solution? So we are given grams of HCl and liters of solution. So the first thing that we should do is calculate the formula mass of HCl. So remember, and I will be looking for this, that everything is rounded with formula masses to 2 decimal places. That way we get the same answer on everything and we have consistent significant figures. So if we look up HCl's values, we have 1.01 for hydrogen and 35.45 for chlorine. So it is 36.46 grams per mole. So that is the formula mass. So remember, formula mass is how many grams there are per mole. So we're going to always start with our grams in this type of problem when we're calculating molarity. So 3.65 grams of HCl, and we want to convert that into moles. So here is our conversion factor for this, 36.46 grams of HCl are in 1 mole of HCl. So that allows us to cross off grams, but we want to be left with moles per liter. So I have the moles here, so I'm going to put the 2.50 liters of solution in the bottom, and I'm not going to put anything up there. Because if we solve this, the units that we're left with are moles over liters, which is our definition of molarity. So 3.65 divided by 36.46, hit equals, and then divide again by 2.50. Our answer should have 3 significant figures according to these values here, and you should get 0.0400 molar HCl solution. Now, if you write just HCl, that's fine. If you write HCl solution, that's fine also. For our second example, we want to know what mass of barium hydroxide is needed to make 3.45 liters of a given molarity. So we're not going to start with a molarity here because we're going to use this as a conversion factor. So these problems where we're looking for a mass, molarity is going to be a conversion factor. So we have 3.45 liters of solution. That's what we're going to start with. Now we want to get rid of the liters, so we're going to use molarity. Remember, molarity is moles over liters. And this means that we have 0.0600 moles over 1 liter. So 1 liter of barium hydroxide solution goes in the bottom, and 0.0600 moles of barium hydroxide goes up on top. So this is our molarity right here. So that allows us to cross out our liters of solution. If we stopped here, our answer would be in moles. But we want our answer to be in grams because it's asking for a mass. So we need to calculate the formula mass of barium hydroxide. And barium hydroxide is 171.35 grams per mole. Barium hydroxide's formula is BaOH2. So we want moles to cross out. So 1 mole of barium hydroxide is 171.35 grams of barium hydroxide. So our moles cross off. We're left with a mass of barium hydroxide, which is what we're looking for. So we would take 3.45 liters times 0.0600, hit equals, and then multiply that by 171.35. The least number of significant figures is 3. So that means that we get 35.5 grams of BaOH2.